So we're gonna go ahead and start. So hi, welcome everyone to today's webinar from Komodor, Codifying Tribal Knowledge, How to Build Long-Term Memory for AI Agents. This webinar is being recorded like all Komodor webinars. You can use the QA section to ask questions in between, and we'll get to all the questions at the end of the webinar. The webinar should be around 45 minutes duration. We'll also send, of course, within a couple of days, the complete recording and the deck of the webinar. So here I'm going to introduce our speaker for today, and then I'm going to hand it off to him. So our speaker today is Nir Adler, no relation, but Nir is an AI innovation engineer on the Commodore CTO team. He works basically on every AI agent initiative that the Commodore team is working on. And the words can't do him justice, so I'll let Nir introduce himself, and then Nir, go ahead and feel free to take it away.
Hey everyone, so yeah, I'm working in the CTO team at Komodor, and I really like my job to do open source and just to develop every time new stuff and learning constantly. And we are going to talk today about agent memory, how they work, how you should do it right, how you should adapt to the right kind of agent that you develop, and how to do agent memory the right way. So yeah, the quick agenda overview, and yeah, so we're going to to talk about agent memory, why we need it, how it's going to improve our agents, how after we doing it right and putting in the right way to implement agent memory, we can get much better agent and much better AI agentic process that lead us to much better outcome. So yeah, so we all know that every agent you have by default a clean context. That's the things that missing in his way of work. Us as human, we have our own memory that have a context that we are building in our mind every time we have any task that we are approaching. So we are trying to bring back memories, how something that I learned before can help me this time, how something that I saw before I can reuse in doing the task that I'm working on right now. Agent doesn't have that by default. Now some of the harnesses like implementing their own memory depend on the harness that you use. There is mostly shipping with their own memory. This is usually like a project-based memory. So like, for example, the Cloud Code, I think it's the most common option that we mostly use and know. So this memory is tied the memory to the specific repo and folder that you are working on. So every time you open the same repo, you will get the same memory that the agent building for this specific repo. But if you have a different repo that also related to the same task, you will not know to gather memories from different repos that related to the same platform, for example. So that's the limitation. And that's exactly where the agent get amnesia and something is missing because in the previous time that you solve a similar issue, you can see it if it's like related to a different repo. So yeah. So how do we actually do memory? How do we store memory? How do we retrieve the right memory? So that's basically the most important part of memory management, how to save and index our memory the right way. Exactly like human brain, you have to put this connection between memories and when is the right time to pull those memory. Just assume if you as a human will pull memories that's not related to the task that in front of you, you will be confused, right? So it's very important to index and store the memory in a way that you can pull the right memory to the right job. If you will pull memories that is not related to what you are trying to solve, it will can like cause the agent to go to a different way and actually go the opposite from what you're trying to do. Instead of giving him the right context to solve the issue, he can go and start, for example, debug in the wrong way. And instead of making it shorter and better, you're making it longer, and probably you can find something else and think that that's the issue while it's not. Yeah. So our agent memory is based on the industry standard. We have our own highlights and improvement that we are doing for our use case, but the ideas is coming from what everyone is doing, but we collect the right approach to our own use case. And that's also what I'm suggesting to you. So you need to understand what kind of memory and what kind of agent are you building. So if you are doing an agent that is very close to entity and you must connect memories to entities, for example, that's the Neo4j example. On the Google example is how you distilled from a running session, how do you get the specific memory from it, and how do you store it and index it, so you can retrieve it in a much fast and reliable way. Okay, it's also open the conversation if we should use embedding and vector database, or we should use fuzzy search, or like the common search that we already know, and it's much faster and easier to manage than vector database. So that's exactly the best practices that you can adapt to what agent you are building. Go next. Yeah, so we already covered it, right? So the gap, the agent start, he have a task, he have a missing context, like if this task is something that I saw before, or something that can help me go and do debugging session better, or who's the person that related to this issue that I'm investigating. So all this context that's missing when I'm starting is what we're trying to do with agent memory. So next time I'm seeing something similar to what I'm seeing right now, I should have these dots and connection that I can connect together to the best context that I can give to the agent, so he can act like it's not the first time he's seeing it. So this is the flow, the most easiest and abstract flow to show the agent memory. So this is highlight the async way to do it. So there is a session, a run, that doing lots of turns. The LLM is investigating or doing, depending on the kind of the agent. So acting on behalf of a task and running tool calls and doing all of that. And that's a long and contextless way. This session is end. Now is the time for us to try to pull out from this session a memories, a notes, something that next session, if we'll have this context, this session will be much faster, a much better way of finding the right what we want to highlight. So it's not just something that we don't want to put in the memories, something like static data, right? We want to say something like, next time you are debugging pod that failed to schedule, this is the way to try to see if that's a node issue, because last time the pod didn't schedule because the node didn't came up because of missing one or three options. That next time when you check the same thing, this is the flow that you should go. Do this, this, and this. So that's a much more efficient way. So next time is not like going to the pod, reading the logs, or it's much faster way. Okay, next time you have a similar issue, go and do this, this, and this. The flow, he knows, and he have the right context that this is a similar issue that he already saw in the past, and that's the memory. And now the agent can retrieve this memory either by calling a tool call to know what kind of memory he have. It's similar to skills on the system prompt. When the agent is starting, we are showing him the titles and the descriptions of the memories, and he can pull the right memories that he needs depending on the task that he's working. So the agent control what kind of memory he actually need to read, very similar to how skills is working. Go. Yeah, so we talked about what kind of data we want to see in the memory. So we don't want to see like static data. We don't want to say every time there is issue, restart pod name payment, right? So that will not be the true all the time, and that's not an efficient way to store it. A memory is mostly when service A is failing, go to service B because it's depend on it, and that's usually the way to go. Go to service B, read the logs, make sure it's up, and that's something that will can be true in time and will not cause the agent to go like totally a different path. Okay, so that's the kind of memory that you want to save, that to say what is the right way to approach a similar issue that we already saw. Keep going. Yeah. So when you store your memories, you need to think on how to label it correctly. That's the best way to retrieve memory in an efficient way that's relevant to what we are actually trying to achieve. So you need to segment, right, the memory to understand, is that related to a specific cluster, to a specific environment, to a specific region? Is that going to help me in containing the issue? Or is that going to help me in debugging session much faster? So you need to know how to segment and how to make the memory labeled, and it depends on what kind of agent, right? So in here we are talking about SRE agents. So SRE agent need to know, okay, this time I'm debugging production cluster. In production cluster, I need to be careful from restarting pod without fallback and stuff like that. So that's a memory that next time when I'm doing a similar task, I know exactly when to start, what is the things that I need to watch for, and that's how you look on your memory. So for the agent to pull those memory, the right one, he need to understand, okay, this is this memory relevant to production, this memory relevant to payment. That's exactly the approach to get the right memory and not memory that will distract the agent. Let's go. Yeah, so those memory have to be maintained. If you are just going to add more and more memories into the storage, you will end with lots of memories. The agent context is going to be filled before it even starts. Okay, and again, it's going to pollute the context, and it can make the agent to make the wrong path instead of the right path like we want. Okay, so memory have to be maintained. You need to consolidate. Like similar memories should be consolidate together. We should clean up duplication. We should try to enforce a memory that we again and again see the agent use, and it's actually work and help him to achieve his goal. So basically, this memory should be reinforced. Other memories that are not used, that are old, it passed long time, you didn't read this memory, the memory wasn't useful, you need to remove it because this memory still take from the context that we show on the window when the agent is starting. We want to clean it. We don't want to show him a memory that in a long time no one read those memory. Okay, so we prefer to save those tokens and keep the memories that actually used and actually put good feedback on the session, and those the memories that we are encouraged, and the other memories that are not used and didn't give a good feedback to the agent, these memories we are cleaning and decaying and archive them so the agent will not see them. Okay, so we are trying to be more and more practical in the how memory work and what is the flow. So we talked about that when the session is ending, we have another LLM session that's starting. This LLM reading the session, understand what exactly was the task, how is it solved, and what was the right node that if I will add this node on this session, on the start, the session will be much faster. It can find the issues faster. It can debug faster. And actually, what was the pinpoint that turned it the right way? So if the agent try to debug production issue and he start from lots of unrelated services and until he find the right service that caused the issue. So we can probably find a note that we will say, okay, next time you have a similar issue, you can go this direction to find those issue in the service much faster. Okay, so that's what we're trying to achieve. The LLM start, read the session, try to find the right node that he can store, and that's what we're trying to extract. And those extraction nodes is going into our memory storage, and the next time the session start, the agent will see if you have a similar issue in production, this is the right memory to read, and it will help you to find the rogue pod that having issues. So that's exactly the flow. So we talked about that's how we store them, and the next time the agent run, he have the way to retrieve. We have a retrieval pipeline, so retrieval is also important, right? We don't want to show all the memory to the agent. We want to clean it. We want to try to find similar and basically we talked about labeling and putting the same memory should not use all kind of agent, right? So if we have an SRE agent and we have another agent for marketing, they should not share a memory. So instead of that, we have a memory. The memory is shared between similar agent that have the similar domain. And between each run that's starting, we are collecting the right memory for this run. Depending on the context of this run, for example, if it starts from an alert, we can go and from this alert, we can find relevant memories and relevant environment and relevant labeling that we can again reuse to clean up the memories and show only relevant memory to the agent. Go on. Yeah. So that's an example how we try to segment the memory and how we process the memories. So the memory spaces is how we differentiate between memory domain. So like I said, SRE domain and marketing domain, it's a different spaces and they will not mix between them. Those spaces can get categories that the agent that trying to find those nodes and memories, he can see those, okay, I'm in a SRE space, I have this kind of tags, of labels, of categories, and that's how I should segment this memory. Like I said, for example, SRE, a good example of segmentation is depending on the environment, the region, what kind of way of debugging, like CLI tools that is very good in debugging DB issues, etc. So basically, the best way you segment it is by doing a very close understanding of the domain and what kind of labels in this domain can help us to find those relevant memories in the next time the agent will run. Can continue. Yeah, so that's example of those agents that doing the storing of the nodes. So the run is ending, and then the agent collecting all what he can from this run. What was the tool call? What was the issue? We can also give him like the context of the issue, the trigger, okay? It's also relevant, especially in our use case, an SRE use case, to understand what was the context, what was the trigger, when it caused, how many times this trigger was alerted. So connecting everything together to a very clean context that you can say, okay, this was the issue, this is how it was solved, and to see the process between them to say, okay, this is the link in the process that if I will know it before, it will be much faster to get the same results in a faster way, and also encourage it to do it this way. So that's how we choose what kind of node we want to extract from the session. We clean it, we label it, we categorize it. We're doing all of that to make it very easy to retrieve it later when we need it. And then we store it in our database. Continue. Yeah, okay, so we talked about this. Most of the session, we try to suggest that you should save a memory. Okay, the issue with that your memory storage will be very, very big and polluted and will take lots of the context from the agent and waste of tokens. So we have to maintain it. How do we maintain it? We make sure the memories that the agent see are relevant, are used, are not rogue memory that we are storing and no one read them in the last couple of months. So they should be decay and removed from what the agent is seeing. So we are trying to make a maintenance. We are doing it each day, depend on how much your memory is filled, what is the rate that you are filling those memories. So we have a maintenance run that go each day and clean all the memories, making sure there is no duplication, because it's now see all the memories that we have. It's not one session. We have a big picture that we are see, okay, today we had 10 memories. This is the session. You can see if these 10 memories have a duplication that you can merge between them. You can see if some of these memories is not relevant, and old memories that you think, okay, this is a new memory that we added today, and we can decay an old memory that speak on something similar in this domain, but this is a much more up-to-date version. So we can decay the other version. So this maintenance keep our context clean, and we show the agent only the relevant memories. Yeah, so if you do it right, and you have a very good way of maintaining and creating those memories, every time your agent start and see something that he already saved memories relevant to these issues, he will do it much faster. He will know how to debug it, what is relevant. He will know how last time he solved it. This is similar to how humans also, every time you have an issue that you already solved in the past, you have a way to start. You know, okay, last time I did, this is the route I solved it. This was the leading point. I read these pod logs, and that's give me all the answer on the issue. And basically, that's exactly what we're expecting here. If the context is right, if we give it the right agent memory, next time you see similar issues, you solve it much faster. Okay, so we talked about different memories. Okay, it's not one way to solve them all. It's very depend on what kind of memory do you create, what kind of agent it's going to serve. So we giving an example for SRE memory. If you are doing specialist memories, for example, the SOC analyst, it's a different kind of agent, right? So maybe you will want to use the Neo4j to do entities, to know very good how to connect an entity to a memory and do a graph of connections between them, because SOC analysts maybe can look on lots of entities in all of my system together at once, and it's much broader way, and you have to make it an efficient so you can retrieve the right one that's relevant to what you are looking at. So that's exactly the example. You need to match your memory to your agent domain. And what's special in this agent domain? So is it entity based? Is it label based? Can you categorize it correctly? You have to use the right custom solution of memory depending on the domain that you are trying to achieve. Go. So yeah, so that's the SRE that we are giving you an example. So that's how we try to segment, right? So we are trying to think, okay, is this memory node can help us debug faster? Like this is the playbook that last time we used to find the issue much faster. This issue usually for example, like dependencies that keep going, DB failure that keep failing a service, but the alert is on the service. Okay, so the agent is going to start and read the log of the service and try to see if the issue is in the service itself until it finds the right way that this service is failing because of the database issues. So that's exactly what we can do with the memory. In the memory, we are saying, okay, this issue, even if you didn't see the specific log that say that the DB is issue, you can say mostly when this issue is failing, you should start your debug session with checking that the DB is operational. That's exactly how the impact is so much bigger, right? Because now my debugging session is much more concise. I have a very specific way to start and see. Maybe it's related and maybe it's not. And that's exactly if I'm going back to how we encourage memories that help us. If the memory help us, so this session will encourage the memory to be much more highlighted, and the next time the agent will read it faster and he will have more confidence that he need to read this specific memory. But if the memory is read and didn't give a good implication, or you didn't use it, or it wasn't relevant, so in time we will try to decay it and we will try to ask the agent not to read it so frequently until this memory will be deleted, unless other agent will find it useful and find the right way, and then the maintenance flow can adapt the memory to be, for example, a better description, so the agent will read it exactly in the right point and not like every time this service has an issue. Continue. Yeah, so we learn a lot about memories, what makes them a good memory. We have to understand that a good memory is a memory that the agent actually going to use, right? Not a memory that's going to sit there and no one is going to use. And even when the agent read it, we want to understand, does this memory help us or not? Because if not, we don't want to distract the agent. We don't want to use tokens. All of that is very important, especially because we are injecting those memories in the system prompt when the agent starts. So it's a crucial point that this memory have to be relevant to the session. And we talked about how we should retrieve the right memory, so how you segment it, how you label it, how you put the right categories on the memory that is relevant to the domain, right? Like environment, region, what kind of service, platform. Like you put the right memory depending on the domain of the agent. How can I retrieve the best memory to what I'm working on? Continue. We use a lot of common knowledge. We read the same thing that you can go and read yourself. There is lots of information about memory and how to do it. Again, you should try to take from all of that, learn, understand, and then adapt to your use case, because that's the best way to get out of it. That's it. Question?
Okay, thank you, Nir. So yeah, we'll open it up before we end to questions. Like Nir showed in the previous slide, we'll send the slides so you'll have all the links to some of the research papers that the team and Nir worked with to understand this. Before we get to some of the questions, I'll ask just Nir. It's a somewhat like generic question, but it's a good start from your experience in working and building like this memory. Is there any sort of like beyond what we talked about today, places where you think you spent a lot of time where it was like a dead end, and how people who try to implement similar things can avoid any like specific like tips or advice on
Yeah,
not
so I
getting those
mentioned
dead ends? Go
Yeah,
ahead.
I mentioned a little bit about that in the previous memory, because now everything is running so fast, and there is like the 10 version of agent memory and how to do it. So it's mostly it starts with vector database. Like you try to embed everything that the agent see, and then the memory was very, very big and polluted. Like to show the complete session from a similar issue, but to show it the complete session instead of just the distilled node, that the actual outcome, that was something that was very common in the past. And I think now mostly we understand that it's not needed, and it's apart from that it's just waste. You waste a lot of tokens, and also like seeing the other agent doing the long flow is not going to be like the agent that see everything together. It can go and do the same thing, Okay, basically do repeat the same issue. Yeah, it will solve the issue, but it will be still long and it will do the same process. So yeah, you make it the agent solve the issue in maybe a more confident way, but it's still long and it's still wasteful. So I think making those notes very, very distilled and very, very summarized and very, very specific, and not the actual data, but how I got there. I think that's the biggest tips on how to do it right and how to make those memories actually useful. And we all want our agent to respond better and faster, I think.
Yeah, yeah, absolutely. And these are just I think what Neil is really getting at. Some of like the battle tested things that have been going on here at like Commodore and how we continue to like optimize those things. So Neil is basically sharing you his war story. So you guys on the webinar today don't go down that war path or that wrong path that we've gone. And basically, like you said, like at the end of the day, it's very easy to explain why because it works much faster and much better quality. Um, I don't see any specific questions on the chat. Someone asked if there's a oh there's a question. So Anonymous asks how we manage sensitive information from being written or stored in the memory.
A what? Like
How do we manage like sensitive information? I don't know if
it's
it's
a very good question. Very good question. So we have different ways of doing it. First of all, we have the most simplest ways of just regex. Okay, we have a set of regex that we are running on the memory and extracting and knowing structure of API keys and stuff like that. That's the first gate. The second gate is the prompt of the agent that actually create the memory. He knows that he need to ignore and remove any secrets. That's the second gate. And the third gate, both of those gates are eventually going to be connected together to the maintenance step that's going to remove duplication and find if the memory is relevant. So the third gate is basically seeing if any of those memory have any secret inside them. It will clean them, and basically that's the way that we are going to remove secrets from the memory.
excellent. Thank you, Neil, for the very detailed answer. I see we have another question. From Hugo asks, um, and I'll read it verbatim. Neil, tell me if you needed to repeat. Can an agent generalize from one failure and apply that lesson to similar situation or to only the exact same use case? How do we prevent outdated or incorrect failure memory from making decisions worse?
Again, great question, and I think that's basically the point, right? What we want to achieve and do right, and that's what's going to do the memory actually useful. So yes, every time we are creating a memory, it's very important. Like I said, I don't want to see a specific data or specific action. Always do this when this. No, we always trying to generalize to say, okay, that's the flow that you should start with. We always trying to give it a toolbox, right? Not a solution. We are not trying to give it a static solution that, okay, take this and this will solve your issue. No, that's exactly the opposite of what you want. You want to give it a toolbox, and a toolbox you can use to a different problem. And that's how you achieve a memory that you can use even in a different issues. Is that cover everything?
Yeah, there is one part. Let me just make sure. He asked Hugo. No, I think how do we prevent outdated or incorrect failure memories from making decisions worse? So I
Yeah,
think
so
you.
we have those maintenance process that we talked about. The maintenance process is what keep us very tight on the memory. He also handled duplication, rewrites, decaying memory that is not relevant. So those maintenance process is what make the memory clean and remove all the unnecessary memories.
Awesome. So, um, so far I don't see any questions. So we'll give 10 more seconds to go questions. Before we end it, and if there's a question pop up, so I'll save my speech for later. Are we currently letting users manage memory? Vajosa asks, meaning update it or even delete it if necessary. I guess this is a question, from users of like Cloud Code.
Yeah, this is another great question. So yeah, so we're definitely doing it right now. We are doing it. It's quite new. We're actually doing even more than what you expect. I think, like I said, different agents need different memory, and your own, like our customer knows their own system better than us. So we have a strong default on how we think, how we see this world of memory, and how do we think we should like distill the right memory from the sessions. But we do give the user to encourage better memories, to edit memories, to even give instruction to what is good memory in his own domain. So different spaces, we talked about this, like different kind of agent um, can be used to different things, and we don't want the same kind of memories. So exactly, we are giving you the users a way to customize as much as possible to their own needs and to bring their own best practices. Like they know their system better than us.
Awesome. Okay, so before we wrap up, I'll just make like a quick. So obviously, you can follow Neil on LinkedIn. He has a very interesting posts, not just on memory, also on like a lot of 3D design and printing. It's a good LinkedIn follow. You'll get like a lot of DIY hack it yourself like projects. So I recommend for like any 3D printer aficionados. Um, we also have next month we'll have like more coming up on everything related to agents, like big announcement coming up from Nir's colleagues and the Komodor team. We have like big announcements in this uh, area of AI agents and how to build and optimize and run them together as part of a platform. So stay tuned. You guys, we'll send a link to that. That's going to be at the end of September. But first, so I want to give, again, thank you so much to Neil. This was a fascinating webinar. Great questions from the audience as well. If you guys do have any follow-up questions for Neil or the Komodor team, you can feel free to get in touch. We'll be happy to help. And thank you. That about wraps up today. And thank you so much. And have a great day.
Okay.
Bye.